As a steam engine, this is a single cylinder engine, has one piston and one valve here. The steam lines supplied from a generating plant would have came into the bottom of here, probably about a 2-inch diameter steam pressure line. It goes, this is your throttle to open and close the valve. So you don't turn the power on and off here with this valve. That allows your pressure to go into this. This is your governor. You would have a belt from your governor to your crankshaft. So as the crankshaft is moving, the belt spins this governor around. This is called a fly ball governor. These weights are spring loaded and they move in and out. So as the weights are moving in and out, as it's spinning, it regulates the amount of steam allowed into the valve chamber. So the faster it spins, the farther the weights move out, which closes up your valve and lets in less steam. So it's very good at regulating the speed of the engine. Goes through the governor down into this chamber here. There's like a small piston here that goes back and forth, which is a valve rather than a piston. It's a valve. And then over here you have one big piston that goes back and forth. So the valve goes back and forth opposite of the piston. And as the valve goes back and forth, it lets steam into one side of the piston, which moves it here. Then the valve goes the opposite way and lets steam into the other side of the piston, which moves it here. So the valve and the piston are moving back and forth. We only have one piston in here with steam alternating on both ends of the piston to move it back and forth. This would be an oiler here. As the valve moves back and forth, it ratchets this up and down. And this is an oil pump. So you pump oil out of this oil pump into inlet here. There's steam cylinder oil that emulsifies in steam. So as the engine's running, it's pumping steam oil into your valve chamber. So you're lubricating your pistons while the engine's running with steam cylinder oil. This is the piston in here. This is called the crosshead and moves back and forth. It's connected to a connecting rod from here to the flywheel. On the other end of the crankshifter, there was a big flywheel, which you run through a belt to your equipment. Let me turn the electric steam engine moving. We ran a belt, which turned that generator. That is a 125 volt DC dynamo generator. This is the forward and reversing lever. You can run this engine forward or reverse either way, depending on how the valve mechanisms move back and forth. You could run the engine forward and backward just by moving this valve. And the amount that you move it adjusts how long the steam is allowed into the steam chamber. You're only looking at about 200 RPMs for this steam engine. So you're generating around 20 horsepower at 200 RPMs. The bore and stroke, it has about a 6.5 inch bore and a 7.5 inch stroke on the main piston. And you're generating maybe 20 horsepower, depending on the steam pressure. This would run anywhere between 100 to 150 psi of steam pressure. Some of these instruments, like this triangle shaped board and this lever here and this thing, these would have been specific brackets used by the engineering students. This would not be here on a factory operating machine. A drum here with a piece of paper. This one even actually has an old paper diagram on this. You would have an elbow sticking out of here, and this would be mounted on this elbow with a valve to turn it on and off. And the steam pressure inside your cylinder as it's running moves this little arm up and down. There would be a pencil lid here that moves up and down on the paper. This one is stuck, but the paper is wrapped around here, and you would have this drum. This string would be tied to this triangle block. So as the engine is running, this triangle block is moving back and forth. It is pulling this string back and forth. The string pulling rotates this drum back and forth. As it's moving back and forth, the string is pulling. At the same time, the pencil pressure is pushing the pencil up and down. So you can see this graph right here. That's a graph of the position of the piston and the pressure inside the cylinder. Engineers would have used that graph, called an indicator diagram, and they can measure the area underneath that graph with another little instrument I have called a planimeter. After we draw the graph on the paper, we have this little instrument called a planimeter. Another steam engine instrument. You would take the paper off, and don't know exactly how it works, but you use this instrument and you can use the pencil pointer and you trace around the area on the paper, and these little gauges over here would tell you the area underneath the graph on that you just drew. So you could use the area, measure this to read the area underneath the graph that you drew. So it's called a planimeter. So it's another valuable or common engineering tool. Here's another instrument I have. It's called a tachometer. You would hold this up against the shaft of your engine right there, and you could read the RPMs that the engine is running while it's moving. Right now, nowadays, there are much fancier tachometers than this, but this is what students would have used. This is another instrument we have here. This was a dead weight tester for steam pressure gauges. In order to calibrate and adjust your steam pressure gauge, you put it on this steam pressure, you would pipe this up to here, there's oil in here, and then you take these weights, dead weights, you stack them on top of here. You can just turn a knob to measure the pressure that's going in here. You directly correspond your steam pressure on your gauge to the amount of weight plates that you have. So that's how you calibrate steam pressure gauges 100 years ago. Another instrument here, not exactly sure what it's called, but it measures the flow rate of steam in the steam lines. If you have a 2 or 3 inch diameter steam line in your factory, you could tap off some of that pressure, steam pressure into here, and I'm not sure exactly, but these things rotate, and you could read the area of the pipe that you have and adjust something up and down here. Not exactly sure how it works, but it's made to read the amount of steam pressure or steam flow rate through your pipe. Nowadays we have lots of electronic equipment for data acquisition, but this was data acquisition 120 years ago. Paper, rotating drum, and pencil.